So now let's go on to problem number 6, which reads, if the point 5, 2 is reflected, what is the equation of the horizontal line of reflection and the equation of the vertical line of reflection if the pre-image point and the image point are the same point? Okay, so it sounds as if they want us to come up with the equation of two different lines. One is the equation of a horizontal line of reflection, and the other would be a vertical line of reflection. And in both cases, the pre-image point and the image point have to be the same point. Well, let's start with our point. Our point is 5, 2. So let's plot that point out on our grid here. 5, 2. It's going to be 5 in the x direction and then 2 in the y direction. So this would be 1, 2, 3, 4, 5, and then up 2, like that. Okay, so this is our point 5, 2. Now comes the hard part. We've got to figure out what is the horizontal line and the vertical line of reflection that keeps the pre-image point and the image point to be the same point. Let's start with the horizontal line of reflection. Okay, a horizontal line is like a horizon. It's a line that goes from left to right, parallel to the x-axis. This is our x-axis. So every one of these lines is a horizontal line. But we have to figure out of all these horizontal lines, which one is the line of reflection that keeps the image and the pre-image and the image points the same. Well, we answered in the last question that if the point lies on the line of reflection, then the pre-image and the image points are the same. So the answer to this question is to find a horizontal line that this point is on. Okay, so would that be a line down here? No, because that point's not on a line down here. Would it be a line up here? No. But what about this line? After all, 5, 2 is on a horizontal line. It's on this horizontal line that I'm approximating with my protractor straight edge. So let me draw this line, and then we'll try to figure out what its equation is. Okay, so I've just drawn a horizontal line, and it's supposed to be sort of just there. So this point 5, 2 lies on that horizontal line. What is the equation of that horizontal line? Well, the equation of this line is y = 2. And that's because if you look at the y-axis, the line crosses the y-axis where y = 2. And for every point on this line, although the x value changes, the y value is always 2. So for our horizontal line, we have the equation y = 2. Well, we do the same thing for the vertical line. So now we've got to figure out, well, here's a vertical line up and down here. We've got with the y-axis itself as a vertical line. Does the point lie in the y-axis? No. So we've got to keep moving our vertical line until we have a vertical line upon which this point rests. Okay, and I think you can see that the point is going to rest on this vertical line here. Just try to draw it as well as I can. We've got ourselves a vertical line here, and this point is resting on this vertical line, and therefore when reflected across the vertical line will stay stationary. It will not move. So the only thing we've got left to figure out is what is the equation of this vertical line. Well, any line horizontal to the y-axis is of the form x equals a constant. So we know that this is x equals something, and I think it's pretty obvious once we know that since x is 5 here, x has to equal to 5. So notice that for every point along this vertical line, x is always 5, but y can be anything. The y value changes from negative to 0 to positive as we go up and down, but the x value on any one of these points is always 5. If you don't believe me, plot a couple of points along this line and convince yourself. So our vertical line is x = 5.